My dear students and parents, in this video we are going to discuss the topic electric field due to electric dipole at a point on the axial line in the chapter electric charges and fields in the subject physics to the plus 2 Cbse students. You can see this fact on the board. By God's grace, my educational videos are available in YouTube to 10th Cbse, plus 1 Cbse, plus 2 Cbse, NEET and IIT students in the subject mathematics, physics, chemistry, zoology and botany in English language. First of all, we are going to take a dipole, that is an electric dipole. The electric dipole AB is taken. At the point A, the minus Q charge is placed. At the point B, the plus Q charge is placed. The center of the dipole is O. The distance between the center of the dipole and the charge plus Q placed at B is A, that is small a. The distance between center of the dipole and the plus Q charge placed at B is small a. Similarly, the distance between center of the dipole O and the charge minus Q placed at A is also small a. Hence, the distance of the dipole is 2a. What is electric dipole? Two equal and opposite charges separated by a small distance constitute the electric dipole. Here, what are the two equal charges? At point A, the Q charge is placed. At the point B, also the same amount of Q charge is placed. So, both the charges are equal. If the charge placed at the point A is 5 coulomb, the charge placed at the point B will also be 5 coulomb. So that both the charges are equal. The first condition is satisfied. The negative charge is placed. At the point B, the positive charge is placed. So that the charges are opposite. Two equal and opposite charges separated by a small distance. Separated by the distance 2a in this case. A point P is taken on the axial line. The distance between the center of the dipole O and the point P is small r. At the point P, a unit positive charge is placed. You are well known that the formula for the electric field capital E equal to 1 by 4 pi epsilon naught Q by R square. The electric field E equal to 1 by 4 pi epsilon naught Q by R square. Here, the plus Q charge will exert the force on the unit charge placed at the point P. Similarly, the minus Q charge will also exert the force on the unit positive charge placed at P. That is, plus Q charge as well as the minus Q charge will exert the force on the unit positive charge placed at P. That is, the electric field is exerted on the unit positive charge placed at P. First of all, we are going to write the equation to find the electric field at the point P due to the plus Q charge placed at the point B. Electric field at the point P due to plus Q charge placed at B. That electric field is taken as E1. That is, the electric field due to the plus Q charge is taken as E1. What is E1? E1 equal to 1 by 4 pi epsilon naught Q by R minus A the whole square. R minus A the whole square. Why we have to write R minus A the whole square in the place of R? This R denotes the distance between the charge, that is plus Q charge, and the point P at which the unit positive charge is placed. Here the distance between the center of the dipole and the point P is given as small r. We need not the distance between the center of the dipole and the point P. Why we need not require the distance between the center of the dipole and the point P? Because the center of the dipole will not exert the force on the unit positive charge placed at P. Only the charges will exert the force, not the center of the dipole. For that reason, we need the distance from plus Q charge and the point P. The distance between the center of the dipole and the point P is given as small r. The distance between the center of the dipole and the point B is given as small a. So if we subtract the small a, that is the distance between the center of the dipole and the plus Q charge from R, we will get the distance between the plus Q charge and the point P. So that distance will be R minus A. So that we are writing the distance as R minus A in the place of R. Then what will be the direction of this electric field E1? At the point P, there is positive charge, that is plus Q charge. At the point P, there is a unit positive charge. Both charges are positive. We know that the light charges will repel, so that the direction of the electric field E1 will be along BP. So it is written as along BP. This is the repulsive force. We are going to write the equation for the electric field at the point P due to the minus Q charge placed at the point A. This electric field is denoted as E2. So what will be the equation for E2? The equation for E2 will be 1 by 4 pi epsilon naught Q by R plus A the whole square. R plus A the whole square. Why we are writing R plus A the whole square? As we have already stated, the distance between the center of the dipole and the point P is small r. The distance between the center of the dipole and the point A is given as small a. So what will be the distance between the minus Q charge and the point P? The distance will be R plus A. So that we are writing the distance R plus A in the place of R in this equation, that is E2. What will be the direction of E2? The direction of the E2 will be along PA. Why? Because at the point A, the negative charge is placed, that is minus q charge is placed. At the point P, a unit positive charge is placed. So negative and the positive charges are opposite charges. So unlike charges will attract, so that the direction of E2 will be along PA. This force is attractive force. Now we are going to write the resultant electric field at the point P, where the unit positive charge is placed. The resultant electric field E equal to E1 minus E2. Can we substitute the E1 and E2 in this equation? Yes, we can substitute, because E1 has been already determined and E2 is also already found, so that we can substitute E1 and E2 in the equation, that is in the resultant electric field E equal to E1 minus E2. If we substitute, the equation will become as E equal to, that is the resultant electric field E equal to 1 by 4 pi epsilon naught q by r minus a the whole square minus 1 by 4 pi epsilon naught q by r plus a the whole square. What will be the direction? The direction will be along BP. Why along BP? Because the value of E1 will be greater than the value of E2. Why the magnitude of electric field E1 will be greater than the magnitude of electric field E2? Because the charge plus Q is placed nearer to the point P than the minus Q charge. So we have to subtract E2 from E1, so that the direction of the resultant electric field will be along BP, because E1 is greater than E2, along BP. Then if we take the common factors outside, we will get the resultant electric field E equal to Q by 4 pi epsilon naught 1 by r minus a the whole square minus 1 by r plus a the whole square. Within the square bracket there are two terms. Those two terms are in the form of fractions. If we subtract one fraction from the another fraction, we can subtract it by finding the LCM. What is the LCM? The LCM is r minus a the whole square into r plus a the whole square. So if we subtract this term from this, we will get in the numerator as r plus a the whole square minus r minus a the whole square. On seeing this r plus a the whole square, it is in the form of a plus b the whole square. On seeing r minus a the whole square, we understand that it is in the form of a minus b the whole square. We are well aware that a plus b the whole square equal to a square plus b square plus 2ab. We also know that a minus b the whole square equal to a square plus b square minus 2ab. Applying that formula, we will get here r square plus a square plus 2ar minus r square plus a square minus 2ar in the numerator. As far as the denominator is concerned, this power 2 is common to these two factors, that is r minus a and r plus a. So we are going to write r minus a into r plus a the whole power 2. If we remove the bracket, we will get the resultant electric field E equal to Q by 4 pi epsilon naught R square plus A square plus 2AR minus R square minus A square minus into minus plus 2AR. This A square, that is plus A square, and minus A square will be cancelled. Similarly, this plus R square and minus R square will also be cancelled. So the resultant data we are getting in the numerator is 4AR. Here there is 2AR. Here also there is plus 2AR. If we add both these terms, we will get 4AR. Is in the form of A plus B into A minus B. That is R plus A into R minus A. We know that A plus B into A minus B equal to A square minus B square. Applying that formula, we will get R square minus A square in the denominator. The whole square is written as it is. So now the resultant electric field E has become as E equal to Q by 4 pi epsilon naught 4AR by R square minus A square the whole square. Compared with the distance R, that is small r, the distance A, that is small a, is much lesser. So that we can ignore that distance A. So if we ignore that distance A, we can put a 0 in the place of A. So we will get the equation for the resultant electric field E equal to Q by 4 pi epsilon naught 4AR by R square minus 0 square the whole square, since A is much lesser than R. Now the equation for the resultant electric field capital E equal to Q by 4 pi epsilon naught 4AR by R to the power 4 along BP. If we cancel 1 R in the numerator and the denominator, now the equation obtained will be the resultant electric field capital E equal to Q by 4 pi epsilon naught 4A by R cube along BP. Now I am going to write 4A as 2A into 2. Why I am going to split 4A as 2A into 2? Because in order to get Q into 2A, why I should get Q into 2A? It is needless to say that the Q into 2A is the dipole moment P. What is dipole moment? It is the product of one of the charges and the distance between them. Dipole moment. Product of one of the charges and the distance between them. What is the one of the charges? Q is the one of the charges. What is the distance between the two charges? 2A. Then we get the dipole moment for the expression Q into 2A. Then we will get the equation as the resultant electric field E equal to 1 by 4 pi epsilon naught 2P by R cube. I have written this 2 as it is. Q into 2A is written as P, so that we are getting 2P in the numerator. The denominator is written as it is. The direction is along BP. What is the direction of electric field due to dipole on the axial line? The direction of electric field due to dipole on the axial line is the direction of the dipole moment. What is the direction of the dipole moment? We know that the direction of the dipole moment is from minus Q charge to plus Q charge. In that direction, we are getting the electric field due to dipole on the axial line. So the direction of the electric field due to dipole on the axial line is the direction of dipole moment from minus q to plus q. At this place, the students should listen carefully. The direction of the electric field is not from minus q to plus q. The direction of the electric field is from plus q to minus q. That is, it starts at the positive charge and it will end at the negative charge. That is the direction of the electric field. Here, it is not the direction of the electric field. It is the direction of the electric field. There is no doubt at all. But the direction of the electric field due to dipole on the axial line, so that the direction is in the direction of the dipole moment. Then what is the unit of dipole moment? The unit of dipole moment is coulomb meter. Why we are writing the unit of dipole moment as coulomb meter? Because we know that the unit of charge is coulomb and the unit of distance is meter, so that we are getting the unit of dipole moment as coulomb meter. My dear students, today we have learned an important topic, finding the electric field due to electric dipole at a point on the axial line. This question is frequently asked in the examination. Then we are going to find the electric field due to electric dipole at a point on the equatorial line in the next video. If this video is most beneficial to you, you can share this video with your friends and classmates. You can also subscribe my channel.